Hello, I am Sudarshan Nayak. Now, after studying of first law of Kepler's, then we go to the second law. Kepler's second law we study right now. So, clean this one. Last class I told you about the Kepler's first law, and we know that all the planets in our solar system moves or revolves around the sun, and the path of the revolution is only elliptical path. All the planet revolves around the sun in the elliptical path. The regular revolution only elliptical path. Now, okay, today I will teach you about the Kepler's second law. What is the second law? After studying the first law, we know that the Earth or any planet revolve around the elliptical path. When the elliptical path, the shape of the path is like this. Okay. I clean this one. It is not cleaning this perfectly, but something. Okay. Okay, enough cleaning this one. So, today's topic is Kepler's second law. Okay, Kepler's second law. Kepler's second law states that like this. We know that all the planets revolve around the sun. Sun is here, S1, that is sun, and here is also center, that is S2. Suppose that sun is at S, and it is the empty foci, and this is the foci where the sun is here. When the sun is here, when the earth like this, okay, this is mass of earth, that is 5.97 into 10 to the power 24 kg, moving with the speed of 67000 mile, okay, mile per hour. Then it will be changed into converted into like how to convert it, okay, miles per hour, that is 60 mile per hour. Like we can change this one 1 mile per hour, that is how much? 67000 into 1.069, that is okay, 67 miles, okay, 66, okay, and 67 oh sorry 67000 into 1.609, that is 107,803, like this, okay, that is kilometer per hour. When we convert it into kilometer per second, that is approximate equal to how much? That is 0.8000 kilometer per hour. when we convert it into like and it is converted, when it is converted into kilometer per second. Meter per second is means meter per second. 108,000 kilometer per second. It is how much? It is 30 kilometer per second, and 30 kilometer per second means how much? 3 into 10 to the power 4 meter per second. I means 30 kilometer per second. It is the huge speed crossing like this. This is the moves revolved around the circular elliptical orbit. This is called elliptical orbit. Okay, and this is the distance. Here is the distance. This edge is called like that is this area. This area is called perihelion. That is called perihelion region. This perihelion regions, and next is aphelion regions. This and this is called, this point is called P2, and this coil point is P1. When the Earth is moving and cross the point, then its distance is how much? This is the distance. This is the speed of the Earth moving around the elliptical path. Earth is moving very high speed around the sun, and its speed is 30 kilometer per second. You mean 67,000 mile per hour. So high speed is revolving around the sun. It is the main reason is that the centripetal force, gravitation of the sun is far away, farthest distance, but Earth is like a distance. How much distance? How much miles this distance? The distance is 91. This is the distance, miles from the sun. At the perihelion distance, this is the perihelion distance. This is the distance 91426384 miles. And can we change 91426384 into 1 miles 609 kilometer, and it is changes how much it is? This 4 into 1.609, that is 1471050 5051.9. You can say 1 2 3 4 5 6. That is called 607 147.105. That is called 1. Okay, 0000. That is called kilometer. This is called, when point is shifted this one, then it is 10 to the power 6 kilometer, and 147.105,100 into 10 to the power 9 meter. This is the distance from the sun. And this distance, suppose this distance, this is called the line joining from the center. This is the line joins from the center of the force. Center of the first force, you can say that it is the S1. This is the center of the sun. Okay, this is the center of the sun. This line, the second law states that the line joining from the sun is swept area by the planet, like this, sweep area by the planet of the earth like this, sweep. This is the sweep area, that's the sweep area by the planet at the region of perihelion is equal to the sweep area of same planet, sweep area of the same planet, or you can say the earth. Suppose that this is earth, this is E. The sweep area by the earth is equal to the sweep area by the earth in the aphelion region. The sweep area, this is called, we write here, the sweep area, the sweep area of the planet, any planet at the perihelion region, at the perihelion region, is equal to the sweep area. This is the aphelion region. This is equal to the sweep area of same planet at perihelion regions, at the aphelion region, aphelion region, at the rate of, with respect to the time, with respect to the time, and this is the area. Suppose that this is the earth, and earth is sweep at the same time at the region of perihelion is equal to the sweep area of the same planet at the region of aphelion, like this, this is the aphelion region. Suppose that this is called, suppose that this one is, suppose that this is the area, and this is the area. Suppose this is the sun, this is the P1, and this is P2, this is P1, this is P1, and this is P2, and this is P3, and this is P4. P3 and P4 at the perihelion regions. This point is at the at the aphelion. Aphelion, and this is the point P1 and P2 at the. This is the distance from the line joining the center, the line joining to the center, that is called sun, and this is the distance, and its distance is too far from the center. Okay, this is the distance 147.1 into 10 to the power 9 million meter. Okay, this is called all peri, and this is the distance. This distance is how much distance is there? This distance you can say that 152.1 into 10 to the power 9 meter. It comes how much the distance from the distance of aphelion, the distance between S1 and P3, distance S1 and P3, distance is S1 and P3. It is the aphelion regions. Aphelion region is how much? This is 94529,804 miles. Okay, when this is the miles distance from the center from the sun at the aphelion regions. Now 452,980 into 1.609. This is how much it is? 9452984 into 1.609. that is 152,098,454.6. this is called kilometer, and the point is shifted. Like this: 1 2 3 4 5 6. That is called 152.09 into 098,454 into 10 to the power, that is called 6. Even you can say that 6 10 to the power 1 2 3 4 5 6. This is 6 kilometer, and convert it into meter, that is 52. This is called 1. This is 1 into 10 to the power 9 meter. This is the distance from the line joining from the center where the sun is situated. Okay, so the sweep lining, like this is the sweep line, this is a sweep. The line joining between the center is swept by the planet at the same time. That is called dt. Okay, and this is called dt. The with respect to time, the same time, whenever the planet is moving around the sun, and it is the elliptical path, and any planet, suppose that Earth, the sweep area by the Earth at the same time at the region of perihelion is equal to the sweep area of the planet like Earth at the region of aphelion is equal each other. That is mean constant everywhere. Suppose this one is area and this is the area. This is the area, sweeping area at the region of perihelion. This is the sweeping area at the perihelion, aphelion. This is the sweeping area by the Earth at the same time at the perihelion is sweeping area by the planet like Earth at the perihelion region. This area and this area will be equal. That is mean constant. So we prove this one. How does it come constant? Suppose this one. This is the maximum speed will be here, and there is the minimum speed. There is the minimum speed like this. This one is minimum speed like this. Now we calculate. Last class I told about the 3.65 into 10 to the power 22 Newton. Okay, this is 3.6 and this is 3.52 something. Okay, now we calculate this one, how it is come. We know that when the planet or any mass revolve in the like a path, elliptical path or circular path, suppose that this is the radius, and in this case the centripetal force will be here. So like this is the r peri, and this is 147.1 into 10 to the power 9 meter. So we put like this one, the centripetal force at the point P1, at the point P1. Okay, the centripetal force is maximum at here because it is the perihelion region. The centripetal force is maximum at P1, and it is situated at the perihelion region. It is situated at the perihelion region. Its distance is how much? This is r peri, that is r peri is called 147.1 into 10 to the power 9 meter. This is the distance. So its maximum speed is here, and here is minimum speed because its distance is large from perihelion. So here centripetal force at the point P, at the point P1, that is mass of earth, velocity of s square of the earth, and r perihelion. This is called peri. Put the value. This is 5.97 10 to the power 24. This is the speed. Speed is how much? 30 km per second. 30 km per second means how much? 3 into 10 to the power 4 meter per second. This is the speed. So we put here, this is the 3 into 10 to the power 4. Okay, this is the s square, and then it is upon by the distance of perihelion. So this is the perihelion distance. How much? It is the distance 147.1 into 10 to the power 9. This is the distance. You can say that we know the centripetal force when the body moves in a circular path or in a elliptical path. There will be the line joining from the center. The line joining between the center is varies with point to point in the elliptical path, but in the circular path, if suppose here E is equal to 0, then the centripetal force is constant everywhere in a circular path. Okay, constant r. This is the constant, this one. If less than equal to 1, in this case, this is like this. Everywhere, this is the radius, this is 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 radius, like this. Okay, this is the radius. This radius is called, this radius is r fp, and this radius is called distance, the line joining. This is the line joining from the center. This is called distance peri. Okay, perihelion. So here is distance is like this one, and the speed is, when the centripetal force like this, mass v square by r, speed is constant, revolve around the elliptical path like 30 kilometer per second. Earth is moves around the circular, moves in the elliptical path around the sun. That is constant speed, and mass of the earth even constant, but here r is not constant. This is variable. So how it is related from centripetal force? That is centripetal force is like this. Okay, let me close this one. This centripetal force. This centripetal is called inversely proportional to r. This is the variable. If the distance is lesser, the centripetal force is greater. If the centripetal force will be lesser if radius is greater. The line joining between S1 and S1 and P2, the line joining between S1 and P3. This is line joining between P3 and S1. P3 is the point at the region of aphelion. So this distance is how much? This one is like this. This is the distance, 152.1 into 10 to the power 9. That is called billion. 152 billion meter from the center of the sun. So now we calculate this one. This is the exact value, how much it will become, how much this and this multiply, 5.97 into 9, 10 to the power 24 plus 8 and 147.1 into 10 to the power 9, and it will be how much? This is 53.73 and 147.1 into 10 to the power 32 minus 9. When 10 to the power plus 9 goes numerator part, then will be this one, and with the exact value will be how much? This is 3.6, okay, 0.6 something, 53.73. This is called how much? 53.73. okay. When multiply divided by, sorry, divided, this is divided by 4, 147.1. it is like this, 0.36523 into 10 to the power 23. When the point is shifted like this, then it will be 10 to the power minus 1. If one digit is right side shifted, point is shifted one digit right side, then that will multiply with this. So we calculate this one, perfect, 3.65, only 2 digit is taken, into 10, this is 5, okay, into 10 to the power minus 1. When this digit is can be written like this, okay, this digit is can be written like this, okay, 1, and it is 10 to the power 23, and write this one 3.65 into 10 to the power 22 Newton force is acting at the point P1. When the huge force is acting at the same distance, then the sweeping area like this, here the huge speed like this. Now it is like this, okay. This is the sun S1, and this is the distance P1, and point, this is the centripetal force is acting. Centripetal force is acting like this. So centripetal force, how much distance? This is centripetal force acting, FC is how much? 3.63 into 5, that is 5, okay, that is 5, 10 to the power 22 Newton is acting at a point P1, and this is the line joining between, this is the line, this is 1.1 billion meter, 147.1 billion meter. This is the line joining from the point to point, and the sweep area by the planet, any planet like this is the Earth. This is the Earth. This the Earth planet is acting the centripetal force. This is the velocity, and velocity is how much? 30 kilometer per second, and this is the centripetal force acting by the sun. This is sun, the centripetal force toward the center of the sun. So here is 3.65 into 10 to the power 22 Newton force acting at a point, and the sweep area is like this. At the same time, suppose that dt the time, any time, that is sweep area is like this. This is the huge speed. This is the sweep area, that is called dA. This is the dA. And now the sweeping area at the region is, we find out the centripetal force at the point here. at the point P3. So centripetal force is like this. This is the 3.52. This is the same thing is here. Now we again calculate this one. Okay, centripetal force at the point P2, centripetal force at the P3, that is mass of earth, velocity of earth, and radius of the, this is the radius, this is the line joining, this is the line joining, this is 152.1 billion kilometer, 10 to the power 9 meter, billion meter. So here is, this is the RFP, this is the RFP perihelion, aphelion. So this is 5.97 into 10 to the power 24 into, this is 3 into 10 to the power 4 s square, and this is the 152.1 into 10 to the power 9. When we calculation this part, then we get 3.52 into 10 to the power 22 Newton, and this is the Newton. We calculate this one. This is 5.97 into 10 to the power 24 minus plus 8. Okay, plus 8, and you say 152.1 into 10 to the power 9. Now we calculate this one, that is called 53.7 10 to the power 32. Okay, 152.1, and this is upward. Okay, and this is how much it will be. Accurate value is 53.73 divided by 152.1. That is how much? That is 0.35325 into 10 to the power, that is called 23. When point is shifted right side one digit, that is this term is can be written 3.53, only 2 digit is written, 10 to the power 1. This digit is converted like this, and this is 10 to the power 23 Newton. This is the unit of the force. This is 3.53 into 10 to the power 22. So you can understand that the Newton acting this 3.53 into 10 to the power 22 Newton force acting at a point P3. Here is greater, here is lesser, then its sweeping area is like this. Sweeping area is just minimum than this one. So here is, suppose that, so this is the sweeping area like this. This is the, okay, this is P3, and it the distance is aphelion is 152.1 into 10 to the power 9 meter, and this is the force, this is 30 kilometer per second, and this is the centripetal force. Centripetal force is how much? This is centripetal force is FC P3 is 3.53 into 10 to the power 22 Newton. This is the force. Okay, here the force, here is force is acting toward the center at the point P3. P3 is at the aphelion region, and its force is 3.53 into 10 to the power 22 Newton, and this is the force acting at a point. Then the sweeping area like this, the sweeping area like this. This is the sweeping area like this. This is P and P4. The sweeping area, this sweeping area, area of S1, P3, P4 by aphelion regions, it's a centripetal force like this. Oh, centripetal force like this is equal to the sweeping area, like P1, this is P2 and S1. This is area covered by sweeping area by the planet at the region of perihelion. This is the maximum speed. Maximum speed will be here. The maximum speed is here. So its sweeping area is larger than at this region, aphelion regions. So larger area is covered due to the centripetal force, larger centripetal force. The lesser area is swept by the planet at the region of aphelion due to the lesser centripetal force. So area is like this. So this is the area. This is the P1, P2 and S1. This is S1, P1, P2. This is the sweeping area by the planet at the region of perihelion at the speed of at the centripetal force is 3 into 3.65 into 10 to the 22 Newton, and this is the sweeping area by that planet at the region of perihelion at a point P. At force is how much? This is the force. The centripetal force is 3.53 into 10 to the power 22 Newton. So this is the sweeping area, this and this. Now we prove this one, how it is equal to each other. How does it equal to each other? The sweeping area at the perihelion is equal to the sweeping area by the planet at the perihelion region. So this is the something difference, like this is the thin area is covered and this is the large area is covered. At the same time, due to the centripetal force or due to the speed of the planet, here is maximum speed. Here the perihelion region, the planet is maximum speed at the at this region, and this is the minimum speed. This is the minimum speed at this aphelion region. This is the aphelion region, and the speed of the centripetal force is lesser. This is the, and here is angular momentum is greater and angular momentum is lesser. Angular momentum is lesser. L equal to R into P. This is the lesser. So this is the lesser, then it will be the lesser. And here the centripetal force, angular momentum, that is R into P. This is the maximum, then it will be the greater. Here is angular momentum is greater. Here is angular momentum is lesser. When angular momentum is lesser, then the speed is greater. Speed is greater. Here is speed is greater, then as the same time that dt, at the time dt, the sweeping area is like this, and at the time dt, the sweeping area is like this. This is the area. So now we prove this one. The Kepler's second law states that the sweeping area by the planet which is revolve around the elliptical path, around the sun, the sweeping area at the perihelion region is equal to the sweeping area covered by the same planet at the perihelion region. Okay, sweeping area, once again, sweeping area by the planet at the perihelion region is equal to the sweeping area by the same planet at the aphelion region with respect to time, with respect to same time, with respect to the interval, same interval of time. So this is the area, this is the equal. This area and this area is equal each other. So now we prove this one. So let me clean this one. Okay. So you always remember that when radius is not fixed, okay, in the elliptical path or in the ellipse where radius is not fixed, there is two type of radius, the semi-major axis, and this is the semi-major axis, and minor major axis, semi-minor. Okay, so here is like this. This is okay, this is like this. This is the center and this is the center. Okay, okay, this one is like this. Suppose that this is called abscissa. This is called abscissa. This is called semi-major axis. Semi-major axis. This is semi-major axis, and this is called semi-minor axis. Semi-minor axis, and this is A is greater than B. A is greater than B, then eccentricity is less than 1, and eccentricity is less than 1 means its equation is like this. This is A square minus B square by root under A square. Okay, so this one is A. You can say that root under A square minus B square by A, that is 1. Okay, this is the less than S1, and in this case this is S1 and this is S2. When the sun is here, sun is present here, then the centripetal force is greater here and the centripetal force is lesser here. Lesser centripetal force and greater angular velocity. Okay, angular momentum, and this is the greater centripetal force at point P1 and lesser angular velocity, angular momentum. This is the angular momentum because it is the lesser and this is the greater. F is greater. So this is the elliptical path. This is the elliptical path, and its radius is not fixed. Its radius is not fixed. Due to this reasons, the sweeping area is just looks like difference. This is the difference. This is the sweeping area. This sweeping area is equal to this sweeping area, but at the same distance. This is the aphelion regions. This is the aphelion. This is P3, P4, and this is the P1, P2, and this is S1. The sweeping area at the perihelion region is equal to the sweeping area at the perihelion region at any at the time dt. That will be constant. This one and this will be equal. That means constant. That means constant. Okay, that is mean constant. That is area. This is the area A1 equal to area A2. This is area A2 and this is area A1. This is equal to, then it is constant. Area A1, area A2 equal to 1. This is the constant. This is constant. A constant. This is when we constant, we prove this one. Let's we prove this. Okay, so here is okay, and this is clean. Rub this one. Let me rub this one. Okay, that one is enough. Clean. Now prove this one. Here now we prove this one. We have to prove the area, the sweeping area by the planet at the region of perihelion or at the region of aphelion while it is moving in a elliptical path around the sun. So this will be constant. This will be constant. Okay, so here is constant, and every constant means this is constant. Now we have to prove this one constant. This is 0. 0 is also known as constant, known as constant. So according to Kepler's second law, the sweeping area by the planet, the line joining from the center, is equal to the sweeping area by the planet at the region of perihelion, at the region of aphelion, respectively, with respect to time. That is, we know that this is the elliptical or ellipse. There is A is greater than B, abscissa is greater than ordinate. So here is like this. Suppose that this is the S1 and sun is here. This is the area. This is P1, and the speed is 30 km per second. This is Earth, and its distance is 147.1 billion 10 to the power 9 meter. Then the centripetal force is 3.65 into 10 to the power 22. Okay, 22 Newton is force acting. Then at the fixed time, at the dt time, is sweeping is like this. So like this, P2. This is the area covered by at the perihelion region. Okay, and now the aphelion region is how much? This is the perihelion, and the distance is a point P3, and this distance is like this. This is the distance. This is the area covered by this one. Okay, and this is velocity of v. This is 30 km per second, and this is 30 km per second, means 3 into 10 to the power 4 meter per second. And this one is this area. Here is the area. We know that. Okay, here is, we know that we draw a normal like this. Okay, and this is the area like this. This is theta. This is angle theta, and this is called perpendicular. This is called the distance. Suppose that P as P3, P4, and this is M. M is the point, perpendicular distance. This is called P4M in the perpendicular distance. Okay, this is P. This is P4M is perpendicular distance, and this is called hypotenuse. This is P3, P4 is hypotenuse. So this is the angle in right angle triangle. P3, P4M. Okay, sin theta. This is the sin theta. Okay, this is the sin theta. Sin theta equal to how much? That is P by H. This is P is how much? This is perpendicular distance P4M upon, and this is H. This is called length. That is called, you can say that curve area. That is and this is delta L. Okay, delta L, that is arc. This is called arc, delta L. Here we say that H is hypotenuse, and it is L2 minus L1, that is L2 minus L1, that is called delta L. Okay, this is arc, this is arc, this is arc. So perpendicular distance is how much? P4m equal to delta L equal to sine theta. This is equation 1. We know that. Actually, we know that this is the perpendicular distance. When the perpendicular distance is related to the trigonometric ratio, that is sine theta. This is the sine theta, the ratio of the sine theta. This is called perpendicular distance. PM is delta L sine theta. Okay, like this. Now we know that the area of a triangle, if there is the base and there is a perpendicular distance. Here is the perpendicular distance, that is the area. This is the area. This is the area. Then it is like this. This is the R. This is the line joining from S1 to S2 is R. This is called distance between center and P3, and this is the perpendicular distance. And then area is how much? The area, that is area like this. Here we write this one. Okay, here we write okay, the area at the dt time. Okay, now at the distance, suppose that here is take at respect to time, at respect to dt, then how much it is speed? This is v1 and v2, that is v and v2, that is the distance. This is distance. We know that at the distance v equal to s by t, then s equal to v into t. So here is delta s equal to v into dt. This is here v is equal to dt, and we put this one, that value is put like this. This is there, here is put like this. That is called, okay, that is v dt sine theta. Okay, this v dt sine theta, this is sine theta. Now we prove this one. Now here we write like this. Okay, like this one. Okay, area, we know that area sweeping area at sweeping area, that is a sweeping area that is sweeping area of how much? S1 P3 P4, area of S1, that triangle S1 P3 P4, and it is at respect to dt. So it is considered that dA. They consider it dA, area at the respect of dt time. So that is area is how much in this triangle? In this triangle, that is half. This is perpendicular distance P4m, and base, that is called S1 P3. So we write here delta A equal to half. This is perpendicular distance is how much? This is perpendicular distance is like this, and this is the radius. This is distance. Sorry, distance. This is distance, and this is the velocity into velocity dt and sine theta. That is velocity dt sine theta. So here this dt is related to the area, so it is differentiate this one. So dA, this dt is brought like this dt, okay, and this is 2, this is r vector, this is b vector, b unit, and this is sine theta. We know that any unit vector, that is, this is the vector and this is mod of vector into unit vector. We know that the unit vector is how much? Unit vector is b vector upon b upon this is. So this is the unit vector. Unit vector is the vector of any quantities upon mod of vector of that quantity. So this is the ratio, this is the video. So this one is can be written is like this, this one is like this, in the same things. This is the reference point at reference distance from the center of the sun, from S1. So this one is this 1 by 2, that is called, that is, what is that is, this one is r, okay, this is r, and this is b, and this is sine theta. And vector is how much? Unit vector into unit vector, that is called unit vector, and that is called unit. So you can say the 1, that is called 1. So we write here, that is like this, that is vector r into unit vector r and unit vector a, and here is unit vector and v vector equal to 1. So 1 by 2, okay, concentrate this one, sine theta, okay. Now we know that here from this equation we know that vector mod of vector sine theta equal to vector a cross b, and this is the relation between the tangent, this is the v, and this is the r, this is the relation, this is the tangent relation, is 90 degree. So here is maximum value is at 90 degree is sine theta. So here this is the formula, mod of a dot mod of b dot sine theta equal to a vector of a cross vector of b. This is the cross product, r vector b is the cross product. This is called cross product. They are related at angle at 90 degree. So here is I can say 1 by 2, that is vector r, this is vector r cross vector b. This is the relation. But the earth is rotating in a circular path, in a elliptical path. So in this case there will be angular momentum. So here is the angular momentum is how much. So we write here, this is the right, we multiply momentum, we convert it into momentum. So here is divided and multiply by m, okay. Here will be how much? 1 by 2, that is how much? R vector cross b vector into m, and this is m, and this is the relation, this relation will be right in this, here we write, okay. Here we write this one. So the area A by dt at the at the perihelion or aphelion. This is the elliptical ellipse. Ellipse. This is the ellipse. Area is covered by ellipse and with respect to time. That is distance, and this is half 2m, and this is called momentum. R momentum. This is called P. P. Here is moment is equal to m into v. This is the linear moment. When the Earth is revolved around the sun with high speed in the ellipse, so here is angular momentum L equal to R into P. So here is how much dA dt. This is the ellipse. Okay, ellipse, that is 1 by 2 m L. This is angular momentum. This is the angular momentum. This is the angular momentum. Okay, this is the angular momentum. So angular momentum is related to the time with respect to when the body is revolved in a circular path, both regions, aphelion and perihelion. So there is time A by dt. This is ellipse equal to how much? This is time taken. This is related with respect to time. Differentiate with respect to time. That is this equation. This equation it differentiate with respect to time. Differentiate with respect to time, because angular momentum is related to the time while the Earth revolves in the elliptical path. So dt by dt, and this is half m, this is L by dt, and this one the differentiate with respect to angular momentum, that is called dl by dt equal to tau. This is the related to the torque. So here is d square a by dt square, that is called ellipse equal to half m, that is called torque. This is again relation. This equals is not now we write at the upper portion of this whiteboard. So place is limited. So first here we write, then we write this type, and after that we write here. Okay. After we write this one in the red color, the red pen. Okay. On the red pen. So here we write here, and this is d square a by dt square, that is a torque. This is 1 by 2 m, and this torque is 0 because torque is 0 Newton meter, while it is rotate in a elliptical path. That is the transitional equilibrium. When the body is moving this here v1 at point v, and at point v2, this is the transitional transitional equilibrium, then torque equal to R into F, that is called 0, because equilibrium transitional total force equal to 0, then it will be total force equal to 0. This is Newton meter. Total force equal to 0. In the transitional equilibrium, the torque will be 0 and torque will be 0, then it is will be 0. And now we write again right here that is dA by dt, that is dt equal to 0, and this one is constant 0, and then it will be how much? dA by dt equal to 0, and then dA equal to 0, and this 0 is called constant. So here is area, distance covered by any time at the region of aphelion, that is the area covered by sweeping area by planet at the region of perihelion at the time of dt, and that area is area 1, and sweeping area of same planet at the region of aphelion, that is called d area 2. This is d area 1, this is d area 2 constant. This will be also constant. D area, this is area 1, this is area 1, this is area 1 is equal to constant, and this is area 2 is constant. When it is this constant, this and this will be equal. Here is right here. This and this area is constant, this area is constant, then delta A1 equal to delta A2, that is delta A1 by dA1 is equal to constant like 1, that is 1. This is constant. So this is the proof of Kepler's second law. Kepler's second law, once again I'm telling this one. The sweeping area by the planet at the region of perihelion is equal to the sweeping area of the same planet at the region of aphelion at the rate with respect to time at the same interval of time. Okay, this is the Kepler's second law. This is the Kepler's second law. Okay, so here is Kepler's second law state that about the area, sweeping area, while the planet revolves around the planet, the sweeping area is equal with respect to time, or with respect to interval of time, with respect to the same interval of time. So thank you so much. Keep watching this video.